Hi, so let us move on to our next part, which is the EDA. So here we will be looking at the data set and its distribution and then try to understand, means try to get some insights from it. So first of all, let us understand the target variable. So for that, what we need to do, we will check the value counts. So df of what is my target variable? Heart attack risk, right? This is my target variable. Close it. Okay. Dot value underscore counts. So see here we are having 5,600 and 3,100. So we can say that means there are more data set samples of 0 compared to 1. That is, he did not have a heart attack. That is less compared to the ones who have had a heart attack. But slight imbalance is there, but it is not a major imbalance. We can also plot it. See how we plot it. plt.figure fig size equals to, this will be 4 comma 4. Now sns.countPlot, here on x will be heart attack risk, and from where I am picking this up, data is equals to df, and width I want this to be thins the bar to be thins, so I'll put the width as 0.4. See, I can make it even more smaller. I'll put it as 3 comma 3. Whatever is convenient for me. Something went wrong. plt.figure equal to fig size. What is happening? This is happening here. Okay, this is happening. No, it should be fine. Yeah, okay. So I got it. So what was our observation? That number of values containing 0 are comparatively more than ones having 1. But this imbalance is not so high that it won't affect our data set that much. Sorry, our models that much. Okay. Second, we will plot a correlation heat map. We'll check the correlation between the features. So it helps us identify the relationship, like collinearity is there or not, means whether our target variable is changing in accordance with our this features. So next is correlation heat map. So again, plt.figure fig size equals to, let me put it as 4 comma 4 for now. Depending upon how the curve turns out, I will adjust my uh, this size of the plot. So sns.heatmap, now here I have to put df.correlation, and here numeric only. This I have to put as true. I'll put annotations as true, and let me use the cmap as coolworm. plt.title correlation heat map, and here comes plt.show. So there we have it. This is what I was talking about. Like, see, it has become a bit congested because we are having many numerical values. I'll first of all, I will increase the size. Let us put it at 6 comma 6. Slightly better, slightly, very slightly. Let us see at 8 comma 8. Okay. So numerical values are there, but see, from looking from the images, you see these all color are blue color only. Means only the diagonal ones are the red, which means high collinearity from this here. And see, so most of these are in blues only. So that this means that most features they are having weak correlation with the target variable. So that means that heart attack means it is depending upon multiple factors rather than a single feature. Moving ahead, we'll do the univariate analysis. Univariate analysis. In this, we'll make histograms. So that will help us check its distribution features. Means how are these distributed? Simply we are going to do see how we are doing it. df of histogram, df dot hist, and say fixed size 20 comma 20, and let us see. Directly I have plot the histogram of the data frame itself. Okay, and plt dot show. So for all the features, I'll get my histogram. That will give me an idea of the distributions, skewness, if anything it is there. Those things will get the idea here. See, we have it here. Again, as mentioned previously, this was generated by, this data has been artificially generated. That is the reason all the distribution we are getting, these are fairly uniform distribution. So no skewness is there, no bell-shaped curve is there. See, generally when we are doing EDA, we don't have to force our conclusions. We have to simply observe the data set and note down our observations. We don't have to force it to be like, why we are not getting it, why it is not happening. Simply, our observation is that skewness is not there. Data is uniformly distributed. Simply, and we have to move ahead. We'll do some bivariate analysis also. See, bivariate analysis. So let us check for heart attack versus age. So we'll see for age versus heart attack. Let us see how to go ahead with it. So plt.figure fixed size equals to 5 comma 5. Now for this I'll have to make box plot. So sns.boxplot, x is my heart attack and y will be my age. I have to give x, y, and from where I have to give data. These three things are to be filled. I'll put title, plt.title. What is my heart attack versus age? And plt.show. So here, what was my x? X I will keep as my target variable, which is the heart attack, and I'll get my target variable. This was my target variable, right? And y is my age. I have to give data also. Data is df. See, so I have it here. Again here observation. We are getting some both are the same only. The both box plot we are getting same. For age heart attack distribution, 0 is also distributed like this, 1 is distributed like this. So age distribution for both classes is very similar. So this suggests that age alone does not strongly influence heart attack in this heart attack risk in this data set. I'll make this curve graph a bit small, 3 comma 3, because for my analysis that much is fine, right? Okay. Now similarly, I will do it for one more. I'll do it for heart attack versus cholesterol. Cholesterol. Again, I will reuse this code and simply I will change this with cholesterol. Just for my convenience, I will get this df dot columns. Let us see, this is the cholesterol. Okay, so I have to change age with cholesterol, age with cholesterol, and I think I'll get my, again same thing as mentioned before, uniform data set, artificially generated data set, so the distribution of both the classes are same. So we have seen univariate analysis, we have seen bivariate analysis also. We did the, so we have done the EDA and we have done quite good EDA. In the next part, we will be looking at the feature encoding and some feature engineering also. So let's meet in the next video. Thank you.